Science 8, it's Mr. Trzynski. I'm going to shoot the video for the energy activity. You watch this video, you should be able to answer the questions. The energy activities in the Google Classroom. You can get that out, and let me go through the steps. Number one, it says part one is to build a string phone. The string phone is made from 2 cups. These are 2 plastic cups and a piece of string. This is a piece of twine that I have here. First thing you ought to do is poke holes in the bottoms of the cups, feed the string through, and then tie a strong knot and a big knot and pull it tight. Do the same thing for the other cup. One person can take one of these cups on one side of the room, the other person on the other side of the room, and the string has to be pulled tight really for it to work well. One of these cans works as a speaker, where the other can works as a microphone. I'm sorry, this would be the microphone, that would be the speaker. Okay? As someone talks into the can collects the sound waves. The sound waves will travel down the string, and on the other side, sort of acts like a speaker. The sound waves will come out again, and a person can listen to it. It's actually a pretty good thing. After I built these, I connected one of them right up to the webcam, because beside the webcam on this laptop is the microphone, and I stood back and tried to talk into it to see if I could get the message in to the computer. And it's a little difficult to hear, but I'll play it for you right now.
This is a test talking on the can string line to the laptop. I'm wondering if you can hear me well. Testing.
One of the issues with getting the can on the computer is to get it down there nice and snug. I had it taped on there, but there was still some space between the edges of the can and the side of the computer, and a little bit of space above the computer where the sound was coming out. Very muffled. If you try this at home, you'll find that it works pretty good. The string does do a good job transferring the sound wave. On your sheet, you'll have these questions. Number 1, build the string phone. Number 2, use the string phone to convey a message in response. Number 3, what type of energy does the string phone transport? What type of energy does the string phone transport? One of those 6 types. Number 4, what is the function of the cup? We talk into one cup, it acts like a microphone. We listen on the other cup, it acts like a speaker. What is the function of the string? Remember, the sound waves are going to get transferred to the string, and the string allows it to transport the message to the other cup. Last question, why is it better to have a string pulled tight? Well, if the string dangles loose, when the sound wave travels through there, it's going to collect a lot of interference. There's going to be a lot of resistance in this method. If we pull that string tight, the sound wave will better travel down the string without any interference. Okay? That's the cups in the string. I'm going to get ready to do the next thing on the energy activity. This is the energy activity, part number 2. It says in step 8, you need to build an electromagnet. An electromagnet is going to require a battery. I have a D-size battery. It's going to require a nail. I'm not going to use that nail. I'm going to use this big piece of iron. It's the same thing as a nail, but it's much bigger. And you'll notice that at the current time, this piece of metal is not magnetic. I cannot pick up this piece of paper clip with it. The third thing you're going to need is a piece of wire. This could be any type of wire as long as it has an insulative cover on it. So there'll be metal on the inside, insulation on the outside. Those are the 3 things that you need to make an electromagnet. And as I put this together and I attach the battery, the core iron is going to become magnetized, and I hope to be able to pick up the paper clip once this is a magnet. Okay, let me get that ready. Okay, and getting your electromagnet ready, it's appropriate to take the wire and make windings around the iron core. Nice, tight, neat windings is a good way to do it. Okay, let's see if I can hold this. There's the wire ends with the nice, tight windings around there. I'm going to see if I can hold this battery up and connect the two ends of the battery with the iron core. Now electricity is passing through the wire, and as electricity passes through the wire, it induces magnetism into this iron core. Now this iron core should be a magnet and pick up the paperclip. Now if I let go of the electricity, the magnetism should disappear and that paperclip should fall off. Here I go. And it's still magnetic, but eventually it'll lose its magnetism and fall off. Okay, I'll be back with the questions. Okay, the electromagnet worked out nicely. These are not hard to build at home. If you were here, we could do it. I'm on the steps of number 2. It says build an electromagnet. Step number 9, use the electromagnet to lift a paperclip. Step number 10, a battery is a conversion device. What type of energy does a battery use, and what type of energy does a battery output? The battery, if you remember from the notes, is made of 2 dissimilar metals and an electrolyte. And as it does its work, it's actually going through a chemical process where electrons move from the heavy electron end, the negative side, to the light electron end, the positive side. Okay? These batteries go through a chemical process as an input and output electrical energy. Step number 11, what happens to the iron core when electricity is passed through the wire? Well, the iron core is nothing but a piece of iron. If you needed something at home to use, you could use a nail, you could use a hanger, but all it is a piece of iron. The interesting thing is when electricity passes through the wire, there is electrical current that influences the electrons in the iron core, and the electrons in the iron core then polarize themselves, and the iron core becomes a magnet. It'll have a north pole and a south pole. Okay? The iron core becomes magnetized. Step number 12, the electromagnet is a conversion device. What type of energy does the electromagnet use? And what type of energy does the electromagnet output? Well, we're using electricity to energize the electromagnet. And when we energize it, it becomes magnetic. And I would answer that question as the electricity being the input and magnetism, magnetic energy, being the output. Okay, let me clean up. We'll go to part 3. This is the energy activity part 3. I'm on step number 14. There's a picture of some batteries there, an array of batteries, and it asks you to list a device that each one of those batteries uses. That first battery up there looks like a 12-volt battery that you might see for a riding mower, for a tractor, or these are the types of batteries cars use. Those sort of vehicles, cars, riding mowers. I think you'll recognize letter B. Letter B on there looks like something that you might use in your cell phone. The battery on C is what we call a button battery. Those are real small. They can go in smaller devices like a wristwatch. This is letter D. It looks like a AA battery. AA batteries can be used in a wide range of things. I think you'll see them used in your remote controls, a remote control for a television, a remote control for a garage door, whatever. This is a 9-volt battery, the little square one. 9-volt batteries I've seen in smoke detectors in your ceiling if you have a battery-operated smoke detector, or, radios. Old radios used to use those. This last one, which was the D size battery, 1.5 volts, those are the types of batteries you might see in flashlights and other types of toys. Let's go to part 4. Part 4 is going to ask me to build an electrical circuit. Let me get that ready and then I'll be right back. This is part number 4. It says build an electric circuit with a power source. So we use one of these AA batteries. Wires, which I have 2 wires which we call allocator clip jumpers. We've got little spring action ends that we can clip onto other wires or other devices. And then the lamp, which is right here. And this is a light bulb, just like an incandescent light bulb, that's screwed into a lamp holder. And this was convenient because I could clip the alligator clips to the edge of the lamp holder. Okay. It says complete the circuit and turn the lamp on and off, which I will show you. Step 17, define electricity. Electricity starts with the word elect, which comes from the word electron. Electricity is the movement of electrons through a conductor. Step 18, in this circuit, what is the energy source? The energy source in this case. Number 19, in this circuit, what allows the energy to be transported? And number 20, in this circuit, what is the load? The light bulb is a conversion device. Number 21, what type of energy does the light bulb use? What kind of energy does the light bulb output? The light bulb is going to use electrical energy. The electricity comes into this side. It goes up through the housing, through the filament, comes back down the other side of the housing and filament and out to that side. Electricity goes in and through. The output here is light that you can see from the light bulb. Okay, let me get that cleaned up and we'll go to the next thing. The electrical activity parts 5 and part 6, they just have diagrams on here. Part 5, step 23 asks you to label potential and kinetic energy. There's a person with a pencil in their hand holding it up. There's a person with their hand is letting the pencil go. One of those is potential, one of those is kinetic. Part number 6, step 24, label convection, radiation, and conduction for that picture. There's letters A, B, and C. One of those is radiation, one of those is convection, one of those is conduction. You can label them down there. Finish the energy activity and turn it in for me for points. Thank you.